There was an interesting report from MIT a couple weeks ago that basically said 95% of agentic projects fail. But the reason for that failure is likely 99% of engineers, programmers, developers, project managers don't know how to actually build agentic systems.
The foundation that you created, the Agentics Foundation, what's the problem it's trying to solve?
Let me be honest, AI gives you sort of delusions of grandeur. But there was a group of us and we saw a spectrum. We saw on one end, we had these vibe coders. And what we were doing was creating architectures and process and approaches that were repeatable with a defined outcome. And what we saw was the term agentics and agentic engineering was starting to be co-opted by large companies who were essentially saying it was an agent, but it was a chatbot or it was a vibe coding system. So we're the stonemasons for this new emerging field of agentic engineering for AI.
One of the things that came out of the foundation was Spark. What was the driving force?
We saw that a lot of the early work within these coding systems were limited by the specification itself. But once we start looking at how do we create larger, more complex applications, it became important to create a specification that the AI could implement, test, and verify.
Before we jump into this episode, I wanted to let you know that this podcast is for developers building with AI at the core. So whether that's exploring the latest tools, the workflows, or the best practices, this podcast's for you. Now, we've had amazing guests like Olivier Pamel, the CEO of Datadog, Matti Stanisowski, the co-founder of 11 Labs, Victor Riparbelli, the CEO and co-founder at Synthesia, and of course, Tessl's very own Patrick Dubois, and they're all sharing lessons right from the frontier of our industry. A really quick ask, 90% of people who are listening to this haven't yet subscribed, so if this content has helped you build smarter, hit that subscribe button and maybe a like. It really does help us keep bringing the folks who are actually pushing this space forward and helping build that AI native future. All right, back to the episode.
Hello and welcome to another episode of the AI Native Dev. My name's Simon Maple and I'm going to be the host for today's episode. And joining me today is Reuven Cohen. You may know him better as Reuv. And Reuv is an agentic engineer. He's the founder of the Agentics Foundation and also creator of Claude Flow, which you may have heard about getting a lot of noise and a lot of adoption just recently. So Reuven, welcome to the show. How are you?
I'm great. Thanks for having me today.
Absolute pleasure. Whereabouts are you calling in from today, Reuven?
I'm just outside of Toronto, Canada, and nice sunny late summer day here. So
wonderful. Sounds good. Now, Agentic. When we think about Reuv, we always think it's an Agentic Foundation, Agentic development with all the things that you've done in and around Spark and in and around Claude Flow. You've been working with agentic processes for years now. Tell us let's start really talking about the state of agentic before we kind of like move into guardrails, Spark and Claude Flow. We'd love to talk about the basics. What is agentic coding? What's the core difference between agentic coding and non-agentic? What makes the difference?
Well, it's been a bit of an evolution for us in the space. And to tell you about Agentics, I have to tell you sort of the brief history of Agentics. And for some people, it's a long history. You know, the idea of agents in technology has been around for almost as long as there's been servers and computers, where you'd have systems that essentially ran sort of, autonomously. So the idea of an agent really speaks to the idea of agency, the ability to operate with little to no human oversight. Now, a lot of the early, agents you would see in applications, things like networks and other components, were very procedural. They would run specifically within a very confined structure. 1 + 1 = 2. But as soon as you went outside of that sort of deterministic sort of perspective, they fell down. They weren't smart. They weren't capable. They just did specifically what they were programmed to do and nothing else. And what we saw really with the emergence of the GPT models, really GPT-3 and beyond, was the ability to use a kind of language alongside of these systems that were then able to use the tools and the infrastructure and the environment in new and interesting ways. And the major breakthrough we had probably around 2 years ago was this idea of a kind of recursive loop. Now, a lot of the early agents and prompt engineering were focused on a kind of chain of thought, right? Do these things and execute, I mean, based on a kind of language abstraction. But it turned out what really made these systems work well was this kind of recursion, feeding errors and logs and successes and failures back into the system so the system could understand the context of what was happening. Once we sort of determined that the context of what was happening was more important almost than what was happening, we could then solve the problems. If there's an error in code, which almost always happens, you would be able to resolve those errors because the AI or the agents themselves could understand what those errors are and resolve them through a kind of feedback loop of sorts. So here we are, 2025. This space, an agentic engineer didn't even exist probably 3 years ago. And as we start building a lot of this technology is what we ended up seeing other like-minded sort of individuals kind of coalescing around myself and others. You know, we had Reddit groups and WhatsApp and Discords, and then we saw large companies adopting the same terminology, agentics and agentic engineering. So it's been a kind of wild ride over the last really few years here.
The idea of this iterative kind of like process whereby we'll try something. If it doesn't work, we'll feed it back in, and kind of like just, you know, looping this nature of trying again multiple times before it provides you with an answer. What do you feel has made potentially 2025 there? Was 2025 the year of the agent or 2024? I can't remember. But you know, when we talk about the year of the agent, is it the ability for humans to be able to trust AI to do these things by itself much, much more? Because when we think about how developers would use AI and LLMs in their coding, it kind of very, very much started off with very, very much kind of like autocomplete style suggestions from an assistant. And then we gradually allowed it to do more, whether it was Cursor or other tools that kind of like did much more for us across multiple files and things like that. What was the thing, do you feel, that really kind of like allowed us to turn agents on in our code generation? Is it context? Is it trust from humans in the process? Is it the capabilities of LLMs?
I don't think it's trust. I think anyone that's building these systems inherently doesn't trust the output and needs to spend quite a bit of time verifying that what it's actually given us is true and valid and functional and not just a kind of mock or simulated version of what we asked it. So there's a tendency for the system to kind of take the shortest path to give you the outcome. So a lot of what an engineer is doing is working with solid structures, architectures, and other things to sort of validate what's being built is functionally true and correct. Now, to your question of what makes 2025 the year of sort of agentics, if that's even a thing, is one of the big breakthroughs last year was, again, this idea of recursion. So a group of us, we created these were kind of systems that could operate on a long horizon. These are agents that could run for hours or days at a time and then eventually complete whatever problem they were given. Now, the drawback to that, we could run it for I think I did a 36-hour test, mostly just to show that I could run an agent, for 36 hours. But the costs were prohibitively expensive. And what we saw as we scaled these agents is a lot of to effectively run this, you're looking at, even on a minimal basis, around $4,000 a day. And when we really cranked it up to dozens of agents running concurrently, we were looking at $7,500 US an hour to run at a 10 agent swarm concurrently, basically. And it's substantially cheaper to hire a person at that point to do that work. It's just, even though you could do a ton of output, most applications didn't require that level of scale or capacity. So in April of this year, what we saw was Anthropic and Claude Code came out, and they started offering a sort of unlimited all-you-could-eat buffet for tokens and capability. And the first thing we did is we sort of imagined the previous iterations of what we call the Spark protocol, which allowed for that recursion. And suddenly we were able to spawn these swarms that could run for hours on end and cost a flat fee, often starting at $20, for an entire month, which went from thousands of dollars to $20, thousands of dollars an hour to $20 a month. So we saw this interesting inflection of both capability. So suddenly we were able to build things dramatically faster and more, or with a lot more capability at an exponentially lower cost, which is an interesting sort of, you don't generally see that happen all at once. And that was basically May.
Yeah, and that's super interesting because I think is that both the making it more affordable, but also the parallelization, it really opens up the quality of what we can actually get back as well as a response. I want to talk about that in just a second. Before we move on to Swarms and Spark specifically, I'd love to talk a little bit about the foundation that you created, the Agentics Foundation. First of all, the Agentics Foundation isn't kind of like super new, I guess. Tell us a little bit about what what the need was for that foundation. What's the problem it's trying to solve?
It's an organic sort of evolution of the work. And I'm going to tell you a little backstory, which is going to probably make me sound absolutely crazy, but I'm going to say it anyway. So I was early into ChatGPT. I was lucky enough to be an early beta tester. I think they called it a VIP program back in 2022 with OpenAI. And so I basically means I got it maybe 3 or 4 weeks before everybody else. And one of the first things I asked it is how can I be, and this is going to sound really egotistical, but how can I be the most influential person in AI? Is what I asked ChatGPT V1 pre-launch. And it gave me this sort of step-by-step process that said, first of all, what are you good at? What do you like? And where do you want to be in a few years? And it suggested that anything worth doing takes years of sort of prep and to get to that point. And it gave me this outline based on a kind of Q&A that you'd have with ChatGPT. And most of you who've ever used ChatGPT and know the kind of, asking open-ended questions sort of routine. And it said basically you're going to have to build a social media following and you should be narrow in that focus. And some, I'm asking, well, what does that actually mean? It says, well, what do you like to do? And I like to build autonomous things. I've been building cloud infrastructure for nearly 25 years, that sort of thing. And it set me down this path and said, first of all, you need to create a subreddit. Now, I know nothing of Reddit or subreddits, but I did it. I followed the guidance and 3.5 years later, I've got 100,000 plus subscribers of the subreddit. I'm not really sure exactly why or what I'm going to do with this subreddit, but it's popular. And then it said I needed to do, and the key was consistency. It said, it told me that I needed to build a following by constantly posting interesting things that I'm doing and sharing those things publicly on my GitHub, creating weekly, live casts where I can interact with people. I followed the guidance. And next thing you know, I have, thousands and thousands of people, showing up for these live casts, following me and essentially buying my time on a kind of only fans for geeks sort of approach where people can sort of essentially buy my time on an hourly basis. And the craziest part of the whole story is it actually worked. And I'm in a fortunate position where I can claim, more than 100 customers, 20 Fortune 500 clients. And I'm literally one guy, one company. Company of one. And my wife actually helps with some of the non-technical parts, but generally speaking, it's me and my bots. And the entire sort of business plan and process was literally set forth by ChatGPT V1, which is in itself just amazing to me.
Did the LLM tell you to create the foundation, or was that something that you've...
The foundation was an evolution of those early conversations. No, it didn't exactly say that. And what happened was, as the community coalesced around the concepts of Agentics and the sort of practical approaches that we were taking to implement the Agentic systems, it became pretty clear that we were in the midst of a new profession. And when you look historically at different professions, and let me be honest, AI gives you sort of delusions of grandeur often. But in this particular case, there was a group of us, and we're realizing that we are all practicing a sort of similar approach to the sort of engineering of AI. And when we looked at it, we saw a spectrum. We saw on one end we had these vibe coders. These vibe coders are not, I'm not saying the vibe coding isn't important. It's a great ideation, learning, and discovery sort of mechanism, but it's very free form. It's very fluid in what you're doing without really much of a plan. And what we were doing was different. What we were doing is creating architectures and process and approaches that were repeatable with a defined outcome. that was an engineering activity. And what we saw was the term agentics and agentic engineering was starting to be co-opted by large companies who were essentially kind of AI washing the concept. They were saying it was an agent, but it was a chatbot or it was a vibe coding system. And we saw this as an opportunity for us to say, well, this is our approach. This is what we believe an agentic engineer as a professional or as a profession should encompass, both technically as well as the sort of ideas of almost like a guild, but for our group of engineering, right? So we're the stonemasons for this new emerging field of agentic engineering for AI. And the group formed around that. It's open. It's the sort of antithesis of some of the corporate-led open groups, OpenAI sort of being the other end of the spectrum, dominated by corporate interests. We said we need to make this for people to sort of empower them both professionally and maybe there's some more aspirational, but as the society around AI takes shape, what does that actually look like, and how do we protect the interests of the people ultimately that are going to be affected by it most? So we want anyway to act as a kind of hedge against trillion-dollar companies. If we can do that. And that was formed in March of this year. And next thing we know, we're in something like 60 cities. We've got multiple events, sort of organic startups or, meetups all around the world happening every week.
And people can just join that. What was the best way for people to kind of like get involved?
Well, we've got a lot of the communication and community happens around either our Discord channel, discord.agentics.org, or WhatsApp. Our WhatsApp's maxed out, so I'm not going to give you the address because when you hit the certain threshold, you basically can't add anybody. But most of it we've shifted to Discord at this point, and Agentics.org. It's a member-led organization, meritocracy, if you will. So if you want to get involved, you want to create a new chapter in a different city, do a meetup. Basically, you just volunteer, and we make it happen.
So if we were to look at the state of Agentic today, what would you say are kind of the things that are creating that ceiling for Agentic today? What are the biggest things that causing Agentic development to fail, or at least to cause problems to developers trying to use Agentic development today?
The limiting factors of the space right now. And there was an interesting report from MIT a couple weeks ago, I think it was, that basically said 95% of agentic projects fail. And it was a fairly sort of sensational title. And when you dig into that a little bit, there's two ways to think about those types of sort of stats. One, 95% of projects fail, which is probably true. But the reason for that failure is likely 99% of engineers, programmers, developers, project managers don't know how to actually build agentic systems. And it's a byproduct of a new emerging space. And it's so the limiting factor is the fact that it's really hard to look beyond this sort of I'm going to call it AI washing, the agentic washing of products, and the people associated with it to determine what the capabilities of the products and the people implementing these products really are. So when you see this sort of high failure rate, it speaks to the fact that we're in a new emerging space. And when you go, if you're old enough to have been around at the beginning of the internet, you would have seen the same thing with a lot of the internet projects that corporations took on back in the late 90s. And there was this sort of, this idea that the internet wasn't quite going to cut it for most business type applications. And then they were wrong. It was the fact that we didn't, as a industry, understand exactly how to build user-friendly internet-based applications. And over time, there were models to follow. Amazons and the eBays and whatnot showed up, and we're like, okay, this is how you create a web-based service that people can easily interact with, and it's not just recreating software. Same problem 25 years later, 30 years later in the agentics and AI space. There's a tendency for people to build applications the way they've always built them, with human-centric models, review cycles, long drawn-out sprints, and different sort of traditional tactics that were optimized for a world where we built slowly over time and gradually. Now we're in a world where we can literally copy anything anywhere at a moment's notice. And the ability, the quality of the code, although important, is less important then the momentum that you get in terms of speed and time to market. So when you're looking at companies that are embracing this, they're embracing this in a way that doesn't just replace their developers. That might be a byproduct, but it augments them in ways that those developers were never able to do before. So you're empowering them with sort of a kind of superpower to create much more effectively and much more quickly, which in itself creates a whole variety of secondary problems. But ultimately, this is the empowerment of developers to do more with less.
And a lot of the kind of like ways in which that can be done in a more predictable way, I guess, is to use Rails or guardrails. One of the things that came out of the foundation, I believe, was Spark, SPARC. Talk us through a little bit about what kind of was the driving force behind Spark. Was it pain in terms of, seeing how people or yourselves were being able to develop code and what the different kind of angle or perspectives you needed from that? Because I know it's obviously very specification based, but there are also a number of different things beyond just specifications which are important to allow your agentic processes to build in a predictable way.
Exactly. And what we saw, if we rewind about a year and a half, we saw that a lot of the early work within these coding systems, but even before agents became sort of popular, were limited by the specification itself. And a lot of the development was happening on a kind of function by function basis. Fix this, copy and paste this into the system, and as you said, a kind of autocomplete, which was fine, and that was not a bad starting point. But once we start looking at how do we create larger, more complex applications with interconnected relationships, data structures, user experience components, infrastructure, it became important to create a specification that the AI could follow, implement, test, and verify. Now, part of that, it was an homage to some of the work I did 25 years ago with Sun Microsystems and their Spark processor. I'm not going to lie, the Spark with a C. And AI is pretty good at creating acronyms. And as anyone can see, the RUV stands for something new every other day for me. But ultimately, the specification allowed for a kind of specification that said, here's what I'm building, a PRD, if you will. And then rather than building the entire specification, what I ended up doing was saying, I need to create a pseudocode outline. So I'm not trying to build the entire code. Obviously, that's going to happen at a later stage. What I want to do is create a scaffolding that allows the AI to understand the general structure of what the code needs to look like before it implements it. So the second stage was basically a kind of rudimentary scaffolding of all the parts of the application. Then once we had that, then we have a defined architecture, an architecture that would be defined based on the code. Once we had that, then we could go through a refinement phase. That was the iteration. The refinement provides a mechanism to say, now we have a pseudocode outline and a defined architecture, which includes all the various parts of the application. Now we can start building that. The refinement turned out to be a really interesting part when we got to the point of a parallel or concurrent development process. So now that we know exactly all the parts of the application, we can get different agents to work on different parts of the overall application independently of each other, although connected through the architecture itself, using a test-driven development approach, which is the completion. The test-driven development approach, and I'm going to give you a quick background for those who aren't familiar with test-driven development. There are essentially two different approaches to test-driven development. The traditional test-driven development approach, sometimes referred to as the Detroit School, which is essentially creating the test as you create the code. And that's what most test-driven development today does. You have a function or a part of an application, you create a test, you write the code, it passes, it fails. That was great for people, but it's not great for autonomous agents building things. The other approach was referred to as the London School of Test-Driven Development. Now, the London School of Test-Driven Development uses a scaffolding. It's basically, developers hate it because you're basically creating the entire application several times. One, you're creating the entire, much like what I defined in the Spark architecture, you're creating the outline of all the parts and how all the parts work before you ever build the application. Then you're building the application. It fails. It always fails. Then you're doing it again. So you're literally building the application at least 3 times, possibly 4 times. But what's interesting about this approach when you have AI agents is, one, they don't actually complain about having to do the same work 4 times. They're AI, and you're doing it really, really quickly and concurrently. So what would take months or many weeks now can happen in an afternoon. And that provides, again, a guide for the AI to follow. And once all those tests pass, generally speaking, assuming it's not completely simulated, your application works. Now, different languages work better than others. So a lot of people ask, what's the optimal language for this? Well, there's Python and there's Node and JavaScript and TypeScript, things like that. But the problem with those languages is they're permissive, meaning that these languages allow you to build with a lot of flaws, and they'll basically work even if they're not right. And then you have languages like Rust, which are very explicit in their definition, deterministic. It's really hard to build bad things in Rust because it just doesn't work if it's not built correctly. So by applying a rigid specification to a less permissive or rigid programming language, the combination gives you the ability to build really, really complicated, hard, broad projects and basically know reliably that it'll work when you're done.
Yeah. And let's dig into a few of those pieces in a bit more depth, because it's really, there's so many interesting things that you kind of like just outlined there. First of all, with specifications, when you look at your specifications and you talk about the capabilities, are you adding effectively high-level test cases as part of the specification, or is that something that is really done at the end?
I'm doing it at the beginning. So I'm
right at the beginning.
I'm doing it at the beginning. So when you follow the Spark spec, and there's different ways, and a lot of people will massage that to their own needs. But basically, what you're doing, you're creating these sort of requirements. What does the product need to do? How does it need to solve the problem? What are the algorithms? What are the flows, the data structures, the authentication? All the things you want in the application. Then what you're doing is saying, how do I validate? How do I test that this thing actually does what it's supposed to do? And that is the biggest challenge you're going to run into in any of these automated systems. Is at the end it says it's done, and it's not. It's a convincing forgery. It's a fraud. And anyone that's ever let a sort of AI run for a while and looked at it and says, well, this isn't true, this isn't right, and that's a byproduct of a specification that doesn't have the tests adequately defined to define what is true and what is not. Right. So when you integrate that as part of the development flow, you can sort of mitigate the potential for fake or fraudulent sort of results.
Yeah. And it also feels like it's a far easier thing to describe when you're talking about the specs and you're talking about the behavior. You're effectively describing tests. It's like it's hard to do one without the other. You then mentioned pseudocode, which is really, really interesting. When we at Tessl talk about specs, we're constantly thinking, okay, should the specs care about the implementation at all? How much should it kind of like go deeper into the implementation, or about the how something should be created? And there's always a fine balance between the what and the how. And it sounds like with the pseudocode, it's interesting that kind of like doesn't necessarily provide language specific information, but it does provide that ability to be able to define parts of the infrastructure, define how I architect this application to be created. Couple of questions in there. First of all, while that I suspect gives the LLM a better way to actually then go ahead and actually create implementation, do you find there's a balance there between how accurate it can be with the implementation, but also how prescriptive you're being with the LLM? Does that provide benefits as well as kind of like drawbacks, or do you find that that's like, the best of both worlds solution for it?
I think the prescriptive, I should say, is a good description of it. What you're trying to do is the more narrow the task, the better the result. So when you look at agent-based development, a lot of times people take the analogy of replacing a developer or a persona. It's not like that. You're not. They don't operate like people at all. And this idea that you're trying to replace traditional human tasks and development approaches with agent-based approaches, this doesn't really work. What you need to look at this is like a multi-threaded development process where each thread is specifically tailored to a particular narrow problem you're trying to solve within a much larger group of threads. And so one thread might be literally one function that calls a data or CLI or some other particular part. And once that's done, it's functional. So an application is made up of many threads that are working concurrently to solve that, being tested. And as you say, it's prescriptive in how it's defined. Does it actually do what it's intended to do? And did I do a good enough job of defining what I wanted originally? Now, sometimes I don't, right? Sometimes you're not really sure what you want to build. And that's also quite exciting, is to explore the unknown and seeing what I can build kind of in a more vibe style. But that said, I still need to be prescriptive in the approach and the tactics that I'm using to build those things. So what this led to things like Claude Flow, which allowed me to sort of share my development approach in a way that was open enough to be interpreted and used in a variety of different sort of architectures, methodologies, and applications themselves, but narrow enough to do so in a way that allows people who don't necessarily know all the things that they don't know to do it in a way that wasn't going to result in a bunch of spaghetti that doesn't work.
Yeah, absolutely. And I guess the second piece to this, and I guess when I first started playing with Kiro as a good example, one of the first things I noticed was when they use specifications, the life cycle of the specification tends to be the change that they're trying to make. So if I were to make a change to an existing application, I would say, this is what I'm trying to do. It would create a specification based on the changes it needs to make. It would create a design style spec as well, and it will create a list of tasks that it needs to do to actually enact that, create that change. If I were to then carry on, I would probably create a new specification for a new change. The life cycle is based on that change, whereas what I'm hearing from you is more that the life cycle of the specification is the application, or is the specification. Is that I guess kind of, first of all, a fair representation of how you think of specifications, and also Claude Flow works with specifications? And we'll kind of get onto Claude Flow in just a sec.
One of the things that I'm doing when you look at sort of my development is I'm using, so a lot of these systems are based on the idea of Markdown, right? You would be able to create a docs folder, plans folder, and create specifications. Those specifications would probably define multiple phases, where you are in the implementation strategy, and it would sort of, iterate through those phases and Markdown files. Now, the issue that we faced when looking at that approach was the fact that it lost context. It wasn't contextually aware of beyond the last MD file, or if it happens to look at the other MD files, where it was in the actual development process. So what I ended up doing was using the approach of a kind of shared memory space. And I made it simple. A lot of people were focused on using vectors and complex sort of similarity searches. It turns out you don't need any of that. It turns out what you really need is a common, simple SQL-like storage environment that allows all the agents to save their current state, as well as access the previous state in a way that was easy for any agent participating in the swarm to see and interpret. Then that opened up two general directions. One was a swarm. A swarm uses the concepts of sort of independently operating agents, or sometimes I call them threads. But these agents were essentially operating with a common direction, a kind of orchestrator of sorts that would tell them generally what to do. And then each agent would be sort of autonomous in the sense that they would be able to make their own determination how to solve that problem. And then they'd update the status and through that sort of shared memory. The other approach, which uses the concepts of a hive mind, which sounds straight up sci-fi, creates the ability for each agent to share the exact context of what's happening at any given point, rather than running autonomously, which I would assume like an ant colony. It might be an example. Each ant has a task. They've got leadership and are orchestrated through the pheromones of the queen, but they are autonomous entities in a sense that they don't share, at least I don't think they do, share conscious constructs between each of them. The hive mind allows you for a common, I'm going to call it consciousness. It's probably the wrong term. A common sort of mind, and to understand what's happening at any given point and then adjust based on it. Solves different problems, totally different development tactics. The hive mind approach is generally better for broad early development. You're going to build a bunch of things quickly, hundreds of thousands of lines of code, and you want it to sort of be more integrated in the sense. Swarm is a little more targeted. So I think of it like a sculptor might. You get a big giant piece of granite, you're blasting away at it at the beginning. Hive mind. When I need more narrow, more details, I need to do the nose and the ears and the eyes. I'm going to use swarms in specific parts of that to really target the different parts of the thing I want to build. I'm building the face. I'm not building the body at this point. The swarm's great for that. So you change your tactics based on where you are in the development of your application and the tools.
Yeah, absolutely. And I guess in terms of, this thinking of, if I'm going to make a change or if I'm going to add something to my specification, I don't want it to necessarily regenerate everything. Is the hive mind also good at kind of like recognizing what needs to be regenerated, what doesn't need to be regenerated, to make sure you almost preserve that history of I guess, context of how everything else has been built? What does that workflow look like?
It's adaptive, which is the most interesting part of these things. They are given a level of autonomy and a declarative approach to solve those problems based on the requirements of the overall project, the current state of the implementation of the project, does it work, what's left to do, and a sort of human in the loop that guides that process. And ultimately, what we're doing here is a kind of, I don't know, it's going to sound crazy, a symbiotic relationship between the AI itself and me, the sort of developer, the swarm master, whatever you want to call it, that helps guide through the steps. What I'm not generally doing is letting this thing run for 6 hours. And, sometimes I do, but more, I'm doing sprints. I'm doing hour or two, letting it solve the hard problems, ideating, optimizing, and then I'm reviewing. Then I'm moving on to the next phase. And I'm the reviewer, and that's an important part of the process.
And as part of that, if you asked for something and then it goes away and actually completely rebuild something, as long as the tests pass, do you care, or is that something that you would consider risk?
I don't trust anything. I validate and verify everything that happens. Just because it tells me the test has passed doesn't necessarily mean I believe it. And it often, now that I've gotten pretty good at doing this, when the test passes, it means it is generally right, but I assume it's wrong. And I need heavy level of proof to validate that it's built it in a way that I like, that it's secure, that it's scalable, that it doesn't hard-coded any ENVs in the source code. And one of the other challenges that we have with a lot of these systems, Claude Code in particular, is the context engineering itself. It starts off great, and after 45 minutes of doing whatever it's doing, it's compacted the conversation a few times and it's lost its context. So the re-injection or reminding, a kind of power steering of sorts for the system is really important. And I think tools like, Reuven Cohen did power steering, where you could sort of have a reminder of where it is every now and again. It works really well. And these systems need to be reminded of its purpose and focus.
Yeah. And this is something that actually that kind of Claude Flow does very, very nicely as well. I'd love to kind of jump into Claude Flow now. Tell us a little bit about this. This is a project, a tool that you created. When did you first release? Actually, it was fairly recent, in the last couple of months.
June 15th was June 15th. Yeah, it was funny, and there's a few things that I learned. I've been on an epic development sort of sprint over the last 2 months. And I've lost count, but last I checked, it was like several million lines of code and a lot of different roughs projects. And so the first version was essentially, I discovered something called the batch tool within Claude Code. The batch tool essentially was an undocumented part of their system that allowed me to move from a sequential implementation of the agent. So if you ever use Claude Code or a lot of these other systems, you'll notice that it does task, finishes the task, moves the next, and moves the next. What the batch tool allowed me to do was create sub-agents, which interestingly enough, Anthropic adopted the same term. No credit to me, but whatever. So with the sub-agents essentially allowed the threads. Each of these things could run in a parallel form all at once. So rather than sequentially, I could spawn 10 or I think at one point I did 500 of these agents. I generally run in smaller numbers and odd numbers wherever possible. And I'm not sure why odd numbers work better, but they do. And essentially what that means is one's doing, a task, another doing another task, and then they can all run at the same time, which took a project that would take me 3 or 4 hours, and I can now do in a half an hour because I had 10 agents running concurrently rather than sequentially over 3 or 4 hours. So the speed was dramatic. It was basically a linear increase in sort of capability, or I guess decrease in time. So 10 agents is 10 times less than, but there's also a sort of max. I noticed that I really wasn't seeing much improvement beyond around 20 agents for things, unless it's maybe doing like machine learning models and optimization. But for most development centric things, it kind of maxed out around 10 or 15 agents. And I wasn't seeing really any improvement beyond that. And at which point I then said, okay, I think this is something that others would want. And because I was doing a lot of work in Rust, I concurrently developed a micro neural network architecture where I ported. One of the first projects I did in the V1 of the sort of batch style agents was basically porting existing complex libraries into Rust. I'm like, what's the most complicated thing I can possibly build? That's literally what I was thinking. And the first one was the fast neural network project, and which I think is referred to as FAN sometimes. I ported that into Rust, made it a WASM, a WebAssembly component that I could run in the browser or on CLIs or servers without any requirements. So it's portable, it's light, and it was around, I don't know the exact number, but substantially faster than the traditional C and C++ implementation. I packaged that up, put it into Claude, into MPX, so I can deliver that through a common NPM or MPX delivery. So if you ever install different modules for TypeScript or Node.js, you do the MPX. So I can deliver these really complex Rust-based components as a TypeScript module, meaning I can get it to anyone, anywhere, pretty much. And I created the first version that combined the idea of an adaptive neural network along with a swarm component, and I called it Claude Flow. Launched it, and suddenly, within a matter of hours, I had tens of thousands of downloads of this thing, and we were sort of inundating Anthropic, and I don't think they were particularly happy about this. So within about a week, I had about 100,000 downloads, and we were doing just billions and billions of tokens through the system. And I'm fairly certain we were a large part of why they revised their model. I'm sorry, it wasn't the plan, but they said unlimited. So in fairness, I was taking advantage of that. And then that led to a sort of recursive development where I could improve the things I was building even faster, because now I had this adaptive neural network that allowed me to optimize specific kind of synaptic components, so micro neural networks that were interconnected to each other and self-optimized. So where traditional neural networks were monolithic, you'd have billion plus parameter models. What I was doing was creating very narrowly focused neural networks that were explicitly built for a task. Trade this one stock in this certain way, understand a particular customer segment, or whatever it needed to do. And so I was creating 10,000 or maybe 100,000 parameter neural network models, and then applying it to the actual application to solve the problem, so we can get really, really smart at that one thing. Trade a stock better. And I didn't need a GPU because I'm using sub 100,000 parameter models. No GPU is required. I could create a neural network in seconds based on the Rust library that does the one thing, and no GPU required at all, which basically changes the paradigms from a monolith to a distributed sort of synaptic network of many small interconnected neural networks that all can collaborate with each other, which is straight up sci-fi.
Yeah, no, absolutely. Walk us through, if you can, or show us, if you can, the Claude Flow in action. So I'd love for the folks and listeners to almost like see the I guess the use cases. Would you say it's more for people who are creating from scratch, or would you say it's more for people who are trying to convert existing applications into a more spec-centric approach? What would you say is the core use case that people pick up Claude Flow for?
I've been working on a new gamified version of the system that allows users to learn how to use it by participating in challenges and different types of sort of gamified version of it. So, it's broad. It's for everyone from early users to, a master agentic engineers and hopefully everything in between. Let me give you a little demo here. Hopefully. So in a sec, what I'm going to show you here is my Flow Nexus development environment, which is a new project I've been working on. Hopefully I'll launch it later this week. Let's see here. What I'm showing you right now is a code space running in GitHub. When you run swarms, remember you're running in a kind of dangerously skip permissions mode within Claude, which means you probably don't want to run this on a local environment. You can. If you're using Windows Subsystem, WSL, and Macs are probably a little more forgiving. I'm running an Ubuntu code space on GitHub in this case. Now, to install, as I mentioned before, I'm using an MPX or an NPM. Now, you can install either way. An MPX, for those who aren't familiar, allows you to run in a kind of remote instantiated version, so you're always getting the most recent version. An NPM style install, which looks something like this, installs it globally but doesn't update it automatically, so you don't get you're getting kind of a moment in time. So generally, what people are doing is they're running an MPX, and to install it, all you're doing is running Claude-Flow at alpha. This at alpha part basically means you're getting my alpha version, and it's alpha until I'm confident that there's no bugs or I stop developing, I suppose. But you're getting the alpha version at that point. Now to verify, all you're going to do is write version. This is gonna instantiate. You can see I'm running alpha 91. Now once we have that, we can run the help command. So this is a CLI, but the CLI is actually an MCP server, I might add, is optimized not for you to use directly. And this is the part that sometimes people get confused by. Most of the capabilities of the system are actually optimized for the system itself to use. So for example, if I run a command to update the memory, I can invoke that command directly. Well, in this case, I got a Riverside sharing. So I'm gonna update the memory. I'm just gonna type this command, session, generate summary, persistent. But the AI is intended to do that. So you can see here, I've been running this for 9,700 minutes. I've done 559 edits. So this is basically giving the context. But if I want to actually build something, I've got a couple different ways to build. I've got my wizard. So I can go, you can see here that I've got different options. So I've got training, I've got verification. There's a ton of stuff in here. So I can start, I'm just going to run the wizard this time. So I'm just going to copy this. And this is going to guide you through the process of running the wizard. So in this case, I'm just going to go and choose alpha. And I'm going to do the Hive Mind wizard. And this guides you through different options for creating swarms, viewing the swarm status. So these are the more human parts of the interface. So I'm going to create a new swarm. I'm going to impress the live cast viewers. Optional name. I'm just going to let it do whatever it wants. Now I've got different approaches for the queen. Interestingly enough, she named herself. I didn't. She named herself Seraphina, which is interesting. I did a little. My wife actually, when I told her about this thing, my swarm gave herself a name, but she's now our mascot. So I'm going to choose. I'll just choose strategic. I'll say 7 agents. I can choose which agents I want. And then I can go and I can choose how the agents come up with their consensus for making decisions. So I can choose different types. I generally use majority. So if I've got a 7-agent swarm, four agents will determine the direction. When you generally use odd numbers, even numbers for
you mentioned that before. Why do you think that is?
Well, even numbers, just if two out of 4 or 5 out of 10 just doesn't really work for consensus.
It's funny how when you actually look at nature, you see so many odd numbers, or Fibonacci, for example, just being used very, very naturally throughout nature's choices. So it's really interesting that that odd numbers, it kind of seems very poignant to me that it naturally chooses odd number, or not naturally works better with odd numbers.
Yeah, it seems to. So I'm just gonna do majority auto scaling. Sure, why not? And then I'm gonna launch Dashboard. No, I'm not gonna bother with that. Still building that. I had an error. I'm in my dev environment, so that no worries. We're gonna invoke that anyway. So in this case, I'm going to spawn, and then I can give it a title. Create a 5-agent swarm to research, I don't know, swarms. And then I'm going to add the Claude to invoke the Claude system. In this case, I'm going to go right here. Oh, I'm having some trouble with that. I'm going to jump I'm going to use a swarm instead. That's the problem with showing you a dev environment. All right, so we're going to go here and we're going to do swarm. I'm going to use the same. So there's 2 modes. It's the Hive mind, which apparently is having an issue at the moment, and the swarm. So in this case, I'm just going to do that for this one. Hopefully that solves that problem. And there we go. So now we're launching an agent. You can see that I injected a bunch of information. This is basically telling it the MCP tools to use, and where we've got different sort of options. I'm not going to do anything. I'm just showing you sort of the process of spawning the swarm itself. So now it's initializing the swarm. We'll see that it'll make use of the CLI and MCP components on the fly. And so here we're dev environment. I should have probably prepped a little bit more, but this is trying to invoke the swarm types. We'll see. It's self-fixing, so we'll see what happens. There we go. It figured itself out. Now, when you see these here, this indicates that it's an agent. So we have color-coded agents. You can modify all these things by going into the agent folder in Claude here, or the commands, which are the / commands, and you'll see that I've got all the different commands available to it. So it's invoking its own sort of persistence. It's creating the tasks. It's using the MCPs and CLIs to do the sort of coordination before it then launches the swarm itself.
And when you talk about the swarm, would you use the swarm primarily because you wanted to have different roles and different perspectives, or do you see it more as a parallelization task where you're effectively trying to get 10 things running out, in the space of one?
Depends. It depends what you're trying to do. So in this case, I gave it a pretty generic sort of guide. I said to research swarms, which isn't really telling it to do much. It's, more just to invoke it more than anything else. So depending on what you're trying to do, you can have different sort of processes that allow it to deploy and work in different manners. So in this case, if I go here back to the MPX for a moment, we'll see the different options. So we've got options here for training. So this is doing all the neural network components. So you can optimize monitoring. You can do those sorts of things. I got a verification system that handles sort of defining is it actually building what it's supposed to? Is it truthful? Is it? And then I've got the ability to integrate people in the process using a kind of collaborative pair-based programming that sort of integrates the concepts of other participants that aren't AI into the process. And so lots of different sort of components depending on what you're trying to do. So the answer is it really depends on what problem you're trying to solve. And that's part of the idea of an agentic engineering system. It's meant that you are the active orchestrator or engineer of the process, and you can make it your own, right? I made this for engineers, not necessarily for vibers directly.
Yeah, absolutely. And interestingly, when you talk about vibers there, when we lean more into specs with things like this, and you can kind of like fire off a number of different agents to kind of like run things, and we get much longer running processes. Do you feel like I've kind of like thought about vibe specking as something now whereby we're still vibing, but we're actually losing contact with our specs a little bit more in terms of reading them firsthand. Is that something that you've also kind of like felt a little bit, whereby you're more able to kind of like interact with an LLM on your specs and then have everything get generated from there, or have you found like the new the new way of development is about this direct interaction that we're having with specifications?
The specs are the most important part of the process. And, people ask me, like, how much time am I spending on the spec versus letting it run? Now, I'm spending all my time on the spec. The letting it run part is just letting it run, but telling it how to run is a particularly important part of the process itself. So without a decent PRD or technical specification, then you're not going to get a decent output.
Are you very spec centric now, whereby the source of truth is the spec? How much do you then touch code after actually like generation from the specification?
How much do I touch? I depends. One of the things that you'll notice when you do AI centric development is there tends to be a cognitive offload. It makes you lazy in some regards, and I'm not indifferent to anybody else. So certain things, obviously, if I want to change a title or do some text somewhere, it's quicker just to up and edit the thing. But even then, sometimes I have a tendency to just say, Claude, go do that, which is kind of silly. I could literally open the file and edit the code in like 5 seconds. And in that scenario, the Claude code is going to take longer to do that. But I'm just lazy, right? Go do that. That's a challenge, right? AI has a tendency to make you powerful, but also make you a little lazy in certain regards.
Yeah, super interesting. What do you think are the next steps from an agentic point of view? Where do you see the agentic future of software development heading?
I think we're gonna get better fidelity. I think we're in the early stages of this, and what I'm showing as a kind of leading indicator of what's possible and what's capable. There's two schools of thought when the people see the stuff that I'm building. It's what they call AI slop. It's like there's no way this guy could build so much stuff so quickly and have it be of any real value or capability. I think the fact that I was able to get hundreds of thousands of users within a matter of days of my platforms indicates that it's probably not. But, it's hard. There's so much there. I get and I understand why people would think that. There's no way for them to review that. There's no way for me to effectively review millions of lines of code. So the assumption that it's bad is probably, understandable. But at the end of the day, the real litmus test for this isn't whether it's bad or good or whatever, is whether, one, it actually solves the problem it's intended to solve. Like, does it actually do the thing that you wanted it to do? Does it? And then secondly, maybe primarily, does it do it in a way that's effective, secure, and optimized, right? And if you can check off those things, then that is all that matters. Now, is it like, artisan code that's optimized line by line, written by someone with 50 years of coding experience? No, it isn't. It's a different thing. But it is something that I could create in a moment to illustrate, or I can create every possibility of a problem and choose the best one, where previously I have to make an assumption and go with that assumption, whether it was right or wrong. I couldn't test every assumption and choose the best of the assumptions because it just wasn't enough time in the day, or the cost, it was cost prohibitive. I can do all that now. I don't even need a team of people. I just need to ask the right swarm the right question.
Yeah. And what would you say is kind of like, as a final question, Reuven, what would you say is kind of like the biggest bugbear right now that you have with kind of either, I guess, agentic flows or LLMs perhaps in an agentic flow? What would you say is the biggest problem that if you could click your fingers and make it disappear, or have a workaround or a solution that today is causing you the most problems with this kind of nice workflow, whether it's through Claude Flow or agentic development today?
Validation, I think, is still a challenge. And I think we've discussed this a few times today. Is it true? Is it real? Does it actually do what it needs to do in the way that I wanted it to do that thing? And ultimately, that is the key here. And it's anyone that's using Claude Flow, pretty much anyone using any of these systems that are suffering through that a little bit, regardless of Claude or whatever else. They all suffer from that same problem.
Yeah, no, I think it's a very fair assessment, actually. And I think it's something that we'll hear again and again with validation. I think it's super important for trust and actually just making sure that what this is kind of, busy building and busy developing is fit for purpose and actually what we want to deliver. Rube, this has been super useful. I would love to, you kind of mentioned where people can access to the foundation. In terms of next steps, if people want to learn more about Spark or if people want to learn more about Claude Flow, where do they start?
I created a new landing page finally. I'm like the shoemaker that doesn't have any shoes for a while there. But I did end up creating a landing page. It's done quite well for me. ruv.io. You can see all my various projects and things that I'm building at any given time. I'm very prolific on GitHub, GitHub/RuvNet, RUVNet. You'll see all my various projects, which runs the gamut from useful to just crazy. I'm just trying to push the boundaries of what I can build and what these systems can do, just because.
Valuable to crazy, you could call that valuable to inspiring, I guess. Let's do that, shall we?
Yeah, I know I'm on the right track when people say it's not possible and you're crazy. And like that's like
perfect. I'm looking at the right things then. That's perfect. Yeah.
If you go back like 3.5 years ago when we started using the term agentic engineering, everyone's like, no, that's stupid. It doesn't mean anything. It sounds like a scientific or medical procedure. That only inspires us to try more and do more. So, we're on the right track.
Amazing. Reuven, it's been an absolute pleasure. Thank you very, very much for all the insights. And I hope our listeners enjoyed it as much as I did chatting with you. So thanks again.
Yeah, my pleasure. And thanks for having me today.
Absolutely. And for those listening, please join us. First of all, subscribe, like the video, and please join us for the next tune into the next episode as well. Thank you very much.